So our site strength and focus areas, reliability, it seems like, especially in immersion cooling, and certainly applies to direct chip cooling as well. Reliability is starting to become an important problem, and we've been working on that now since we started immersion cooling. Direct to chip liquid cooling, cold plates and especially we're working with a company called Fabric 8, where we use electrochemical additive manufacturing to develop some pretty fancy cold plates. Heat capture ratio we feel is very important for hybrid cooling. What percentage of the cooling is done by air and the other by liquid. So done a lot of work on publishing this area. Single and two-phase immersion cooling, under progress component and server level study for two-phase cooling. Indirect evaporative cooling. I still feel that this whole idea about maybe Russ might disagree with me that air cooling is gone. It's not quite true. Maybe for hyperscale and AI, but there's still quite a bit that rely on air. So we have one project on indirect evaporative cooling. So in fact, this is the first project here, Mestex. We're looking at characterization of development of an indirect evaporative heat exchanger. In that we have both a direct evaporative cooling where we use spray nozzles, and then cooling media pads, and then we have the primary side is air, which will not be contaminated. The other one could have contaminants. We've done a lot of work in there, published extensively about the impact of contamination on servers, whether it's copper or silver and what impact that has. So we've done a lot of work on that as part of the ES2. Not to lecture anyone here since you guys are all the experts, but look at this number here. We're still, the relative and absolute number of high power servers deployed today are relatively small. We're not going to say that about AI systems, obviously, but there's still some demand. I can tell you that people have talked to us about our indirect evaporative cooling work. So this is what we're doing with Mestex. And this is the system, and you can see that it's quite a bit of work in this particular. So this is still ongoing. I want to tell you that Mestex stopped giving us cash, but there's a very good chance they'll be back, and there's some contact with other companies where they might team up and start supporting this. But just like we are about to get rid of immersion cooling, and I refused to get rid of it. I think there's opportunity here. So my group, just out of our own budget, continue to work on this. Heat capture ratio, this is May-Sam and Sai. They have presented this at this last meeting. So the thermal and flow parameters of the hybrid cool server. The status is simulation experimental study on CPU server has been completed. And what is left is setting up simulation experimental validation for a GPU-based server, and we have the GPU-based server now. So May-Sam and the team will be working on it. And this is study a single-phase indirect liquid cooling cold plates, including use of additive manufacturing. This once again is working with Fabric 8, and we're very excited about it. And we published a journal electronic packaging paper on that. And this is some of the really fancy designs that we've had, and bottom line is it was able to really generate very, very high performing compared to the baseline case. And then this is single phase and two phase immersion cooling. Again, a lot of interest in this. I think the reliability, once again, is what's really important. So we're doing a lot of work in reliability. We're immersed several uh, uh, samples of copper, brass, and aluminum, and so on and so forth, and tested. So uh, uh, we feel we have a very state-of-the-art lab to do this, and we're a bunch of companies are interested in evaluating, especially their thermal interface materials. And this is single phase and two phase immersion cooling, thermal reliability. This is a substrate core. So again, one of the problems we have is we didn't we got two new environmental chambers, but we still need more. But we're in this particular case, the oven is sufficient. So the key finding is there was some material property change in elastic modelers, and glass transition temperature pretty much stayed the same. And data center environmental burden reduction through water and carbon recovery. We're especially, I mean, this is work really was Villanova. We're especially excited about this now that we may have a bigger lab, that I think we have an opportunity to start looking at sustainability and work with folks in the chemistry department in this particular area. And this is environmental burden reduction through water and carbon. As you guys know, that the water consumption of data centers is really huge. And if we start looking at, for example, our direct-to-chip evaporative cooling, that's really on a separate ARPA-E. There's really hardly any use of water. So it's I think that two-phase has big capabilities in reducing water consumption. Students that graduated, I must be showing, unfortunately, let me see. Well, this, I made some change in the slides that didn't show up, but Gautam got his PhD in December. He's now Fabricate. Akshay is at Tesla. Himanshu is at NVIDIA in the last year. Jacob and Joseph finished in August, and they're now in Delta Electronics. Braxton Smith, interestingly, he's a student right from UTA, had a 4.0 GPA as an undergrad, joined my group as a master's. He's doing really well, and he's being supported by ARPA-E, but he also works a little bit in related to the Fabricate project. And I'm always excited when people come to our group, finish and leave. Vishal Talari, our postdoc, just started a job at ANSYS this week, so we had a big party for him. And this is some of our facilities. We have a 240 kilowatt data center lab, in which we have tested many things, cold plates and so on and so forth. We work with a lot of folks, probably in here, people, especially from Vertiv and NVIDIA and so on. We primarily want to acknowledge that NVIDIA is really the main supporter in this particular lab, but it's been used to do a lot of things here. We have the good old airflow bench, which we feel that we're experts in characterizing cooling media. We've done that for many companies in the past, and interestingly, that's not going away. A company that probably surprised many people has come and asked us to work in wet cooling media work. And this is our PIV system. This was Intel. Because of Intel, we purchased this. It's $400,000, and yeah, we're very excited about it. We got funding from Intel for 3 years for $300,000. Part of it to Villanova and Binghamton. We didn't get funding this year, but we're hoping we can get funding in the future again. And this is the submerged tank. This is their, state-of-the-art tank in our lab. It's 350 kW. So we're doing a lot of work, interesting stuff, especially in targeted cooling, um, and other opportunities for extending single-phase immersion cooling. In fact, one of my postdocs has shown that single-phase immersion cooling, the baseline case was 600. Now he's shown he can cool 1 kW. So some of you probably have seen that in our lab. And this is work we're doing with Chemours. We're evaluating their 2P70 coolant, and we've been running experiments for the last 7 months. And these are some of our setup, ASTM setup, our TI 980. Proud of it. We paid $600,000 for this, and we have a TIM tester, brand new. We built. We want to acknowledge Honeywell and NREL for helping us in the design. And I don't know if Honeywell folks are here, but they're interested in running some, doing some work with this new machine. The interesting thing about it is most temp testers are, 1 inch squared or maybe 2 inch squared, but this is 3 inch. So it can really look at some of the latest, chiplets, big chiplets. So we can, and this is our new chamber, $90,000 just for this chamber. We have two aspect chambers, but we still need one more chamber. Our thermotron chamber is ready to get thrown out. So, and oops, this is a big highlight. This just happened. We received a 9,600 square feet lab. I thought I may have a better picture, but that's okay. This is good enough. But we've had lots of meetings, several hours of meetings. The president approved this, and so obviously any equipment donation is fine, but there's going to be some opportunities to work with the local data center companies, big data center infrastructure in the North Texas area. So this has its own parking lot, and so officially I'll have the keys probably Friday. So this whole thing, including parking lot and so on, will be our new data center lab. And the most important thing about it is it's right by the street. So we were in the process of trying to upgrade that our lab, Netterman NH113 to 115 to 3 megawatts, and then have maybe a 500-ton chiller. That was going to be very, very expensive. Now we can do the same for half the price, or we can, our plan is really to have 6 megawatts and maybe 1,600-ton chiller. So there's going to be a lot. So all our lab data center related is going to eventually move here. So again, the dean's office had put a high priority on this. So we're meeting almost every day on this. Yeah, more again about that. And this is something this is related to the ARPA-E project, hybrid cooling. We work with a company called Excelsius. They provided us a 250 kW two-phase CDU. And yes, and we received a bunch of GPU-based servers. So we're going to populate this. I mean, we've been able to show for a single server that we're able to meet the criterion ARPA-E provides. So again, that's synergistic kind of work. Uh, you know, Fabric 8, we're interested in looking at erosion. We've done a lot of work in this, there's actually an OCP presentation by one of my students. And yes, so I think there's big opportunity there to do work in that area. Meta, we're working with them on a potential SOW, and then the TIMS again, Honeywell and NREL. Here's some of the new projects we're thinking about. Again, with our new lab, that I don't know, it's going to be a lot more things that's going to happen, but this is some of the topics we have in place. And related to, you know, related to uh, we've been to many conferences, and I would just show you just a couple of things, just so you can see. Uh, well, it's okay, but we've been to 724 Exchange. We had 9 people there just recently in the end of right after well, it was right after iTherm, June 6th to the 9th, and we were actively involved in iTherm. Let me just show you. I'm about 5 minutes away from finishing, but what happened is I had a version that had all of this, but uh, I didn't save it. So conferences, uh, you know, this was in June, a 724 exchange. All of the students, including postdoc, attended. We feel it's very important to do that. We also attended OCP. In fact, we have 2 papers at OCP this year. And iTherm, we hosted a bunch of folks to come and visit our lab, and I think some of you may have been there. So this was the meeting we hosted, both academia and industry were there. It's pretty exciting. And yes, so some old friends as well. You guys probably know this guy, right? Chandrakant Patel. He's now retired. Used to be at HP. So I think that's probably all. And then I'll be giving. I gave a keynote at. An invited lecture at University of Illinois Chicago in April. I'm going to give a keynote at IMAPS in October, and then I have an invited talk both at Georgia Tech and UCLA in the fall. So with that, I'm going to stop and ready for questions. Can you guys hear me? Hello?
Yes.
Yeah, yes. Okay, I'm gonna stop here. Russ, I'm expecting some equipment from you for that, 9,600 square feet. Hopefully, if you can fill up 8,000 square feet of that, that'll be good. Then we can manage the rest of it.
Uh, I had seen that Tim Schrader, who I report to, was on the call earlier. And unfortunately, Greg Ratcliffe is not on this call. I know
But that's a,
Greg earlier in the year had said, "Oh, Vertiv needs to donate stuff to UTA for a lab." And I said, "You need to be a little more specific than donate some stuff." And, and nothing came out of it. Uh, an initial thing to come out of it was, I believe it, Andrea has a place for this presentation to go. And I could send this presentation to
sure.
off to Greg and remind him and say, uh, yeah, the position I'm at, let's see. When I used to manage the lab, I spent all kinds of Vertiv's money, and I think they decided they don't want me spending their money anymore. Uh, so now I have to ask other people if we could spend their money, uh, spend Vertiv's money. So that's the position I'm in. Uh, so this presentation would be great to get Greg Ratcliffe in particular to say, all right, do you have money to for UTA to donate some things? Uh, we need to put and talk with you, Reggie, to say, yeah, obviously I could find some environmental chamber, and then it'd show up at your doorstep, and you'd say, "What in the world is this?" And
Oh, that's good. Yeah,
yeah, we can't do
yeah,
that. It needs to be need to work with you as say, so what projects you're working on, and
yeah.
what apparatus do you need?
Yeah, I want to tell you that when we were talking to Greg, we didn't have this 9,600 square feet lab. So
Yeah,
this is brand new, just happened 2 weeks ago. And officially I said I'll have the key this Friday. So it they're putting a lot of effort in this, and I think that I would have to say that ES2 is the catalyst for this happening. So we hope that we can expand the projects we're working on.
fantastic.
And yeah.
Regarding
Yeah,
the
yeah,
regarding
before
your
our lab was just we still our lab altogether is about 7,000 square feet, but the one, for example, what we have in Media Labs was only 2,000 square feet.
yeah,
So we're limited, and to get in there, to get power, to get anything, to get CDUs. Now we can test CDUs. I mean, commission CD. We can commission chillers, right?
yeah,
And potentially work with the Stargate and so on, right?
yeah,
And, so there's potential for that kind of big thinking. So I can talk to you
yes.
about it. So
Cool. Yes, this presentation is exactly uh, a summary overview is perfect so that it's I could go to this and say I need a refresher of what Reggie and UTA are working on. I go to this and then I can speak more intelligently about it. So congratulations, you did a really good job. on this presentation. Uh,
Thank you very
so
much. I'll update.
yeah,
There's a couple of slides I had added, but
yeah.
unfortunately, I didn't save it. I was just doing it to the last minute. So
Yeah.
only a couple of slides, just pictures
Okay.
and so on. So
Cool. I know
I'll send it to you.
Vert is particularly interest in the past 5 years. If you say in liquid cooling, uh, yeah, from my vantage point, what I see is that the market, the world has said pump single phase, that's the winner. And particularly for all the AI stuff, that's where everyone is going. Uh, it's it's not completely mature. Uh, most of these things, if you say, "Oh, I'm selling all kinds of stuff," well, you think it's a mature market or mature products. Say, well, no, it's anything but. Uh, so there's a decent amount of work to is necessary to mature the pump single phase. And then you say,
Absolutely.
are there limits to pump single phase that some other
Yeah.
technology can
Yeah.
overcome?
Yeah.
And so we're particularly interested in the pump two phase work you are doing.
Yeah.
Uh, and pump two phase has its own set of issues. It's got some very solid advantages over single phase and some very significant challenges. Um, and those need to be addressed. So yeah, we're very
Yeah.
interested in working with you on
Russ,
those.
on that point, we actually have a proposal with Intel, uh, uh, OCP. We're working with Dr. Andrea Yates. You probably know her, and
Mhm.
yes, the reliability of both single and two phase, but the two phase a lot more acute. I have a whole 60 slide I can talk to you about that, but yes, it is very important to look at. I also want to tell you this was my presentation. We were honoring the VJ Deer. I know, but God knows him very well, former dean of UCLA. I gave an invited talk honoring him, and it was implementation of liquid cooling for hyperscale AI data center challenges and opportunities. If you want me to, I can also send you. But one thing that might interest you here is I talked about Back to the Future and talked about the work. This is the work that uh, that uh, you know, IBM and so on and so forth did. Uh, I'll just show you. Uh, this
Yes.
should really you should really like this. I'll
If
let
if
put
you
it.
could share that presentation, I
Yeah.
would appreciate it.
Yeah, I want to show you if you in that presentation that was a shortened version.
Yeah.
I said Back to the Future and showed. You remember this? A 5 megabyte hard drive shipped in by IBM. I know, um,
Yeah.
and this is 5 terabyte, and then just showed a lot of the work. IBM been doing liquid cooling since early 60s. This is inner board heat exchanger and also Bob Simon's liquid encapsulated module and stuff like that. The TCM liquid cooling, all the stuff we're talking about, quick disconnects and so on and so forth. Bagat did all this reliability stuff, by the way. So, and this is the modular refrigeration unit, the Roger Schmidt. It's so there is a lot of Back to the Future that people tend to forget that IBM and Intel has done a lot of work on it.
Yes.
You agree?
Oh, absolutely.
Okay. If there's no additional, so I see here any other companies here. I know I need from a postdoc from a PhD student from UIUC that we work with in ARPA E. She just joined Honeywell. I don't know. I don't think she's here. Not that many folks here. So, all right. And yes, we want to say that quite a few people now are seem to be joining Tesla as well. Obviously, NVIDIA, we're very excited. I now have 5 former PhDs working there in various aspects. So that's not just us, obviously, people from Villanova and a significant number from Binghamton. So I think we as ES2, I always have to say it was Bhagat's leadership, right? You need someone that people respect, and I'm not trying to be nice to you, Bhagat, but everybody respects you. So, so you can handle all his egos, including my little ego. So, so thanks for your leadership, really.
Thank you, Raji.
Okay, I'm done.
So
Yeah.
I guess the question to the industry attendees is, did this go according to what you were hoping for in terms of an overview? Russ, I think you said you are satisfied with the approach, right? This is similar to what we did last week.
Yes. I yeah, this is perfect because it's a compact overview that allows me to look at that and say, refresh my memory so I can have specific search for specific things. And it's very much, excuse
Awesome.
me, what's needed. And it also allows me to communicate with the people at Vertiv that that are looking at where is this industry going? What does Vertiv do? Where do we apply resources uh, to stay relevant and more than relevant to lead in the industry? So these
And
summaries
keep
are,
Jim Cramer talking about you.
yeah. So these summaries are very good for that purpose.
Excellent. And it's also great news that, the Reggie added all this space to the center and that he, in future, UTA will have opportunities to test commercial level equipment.
Yeah.
And so
Yeah.
I think it's great news.
Yeah, thanks. Yeah, yeah. There's some
Absolutely.
plans, 1 megawatt racks and so on and so forth. We now will have the capacity to do that. And there's also other folks talking to us about testing a whole bunch of stuff and then optimizing and this and that. So Russ, I can talk to you offline sometime about that as well.
Sure. Yeah. It amazed me, not too long ago, 50 kilowatts was a whole lot in a rack.
Right.
And now it's like, oh yeah, we'll just make a 1 megawatt rack.
Right, right.
And
It's crazy.
the other thing is, and the computers, they still are using like 5 volts DC. So how do you get 1 megawatts worth of 5 volt DC distributed around inside a rack. So I know that ES2 is looking a whole lot at the thermal part, but the power part is
Yeah.
really challenging. Do you bring medium voltage to the rack and then start reducing from there? When I say
Yes,
medium
there's a
voltage,
company, yes, there's a
yeah,
company, someone broke away from CommScope we used to work with. They're talking to us about very excited about doing some power related stuff in this new lab. This new lab is opening up all kinds of, I'm not kidding you, we have meetings, several meetings a week, sort of. So again, I'll talk to you offline about this.
sure.
Well, thanks, Raji. Excellent
Thank you.
presentation. Yeah.
Thank you. Thank you, Bhagat, again, for your leadership, and you guys have a superb day.
Yes, you also.
All right. Thanks,
All the
Lucille.
best.
Bye.
Yes.
Pleasure.